Hi, and welcome to section 6, Text. In this section, we are going to learn how to work with the newly introduced Precomputed text class, which improves the performance of text layout operations, how to make use of the new magnifier class, which allows the user to very easily magnify certain parts of the screen, and how to work with the enhanced text classifier class, which allows to detect email addresses, phone numbers, links, and more automatically from a given text source. Precomputed text. So we are back here with another tutorial video about the precomputed text class. And before getting into the actual coding, let's have a look at the outline of this class. So precomputed text was newly introduced in Android 9, and it is designed to improve the text layout performance when text strings or characters are set for a text view. And the actual performance improvement is done by performing the expensive layout operations, which are required when text is set for a text view beforehand. And the result is then cached and used later on by the text view. Measurements have shown that this behavior can improve layout performance by up to 90% compared to traditionally setting text for a text view. And performance is specifically improved if this operation is performed on a background thread, which is what we are going to do in our example. So without further ado, let's head over to Android Studio. So basically I've set up a brand new Android Studio project with some things already in place. So in order to showcase the precomputed text properly, I've decided to implement a recycler view. So if you have a look at our activity main layout file, you can see that there is a recycler view in place. I've already created a item layout for my recycler, which is just a very simple linear layout that contains a text view. Then my main activity class is empty so far. And what I've also already done is set up a very basic recycler adapter. And this adapter basically takes an array list of strings, which is going to be the data it is displaying. Then here we can already see that I've inflated my layouts, so my recycler items. On bind view holder, I am setting the text for my text view, which is obviously what we are going to change and replace with some precomputed text. And I've also created my view holder, which just holds the one text view I have in my item. So let's head over to main activity and populate this recycler adapter. And we're going to do that by just creating a very simple for loop. Just putting 100 items into my recycler adapter. So I'm creating the array list that I'm going to hand over to my adapter. And let's just append or add some items. Then I'll have to set up my recycler view. First thing we need is a layout manager, which is just going to be a linear layout manager. Then I'm going to set the adapter. So I'm using my previously created recycler adapter class, and I'm passing my data, which is the array list I have created up here. So this should already be sufficient for displaying my data. So let's run this sample application real quick and see what it looks like. Heading back over to the emulator. The application should come up in just a second. And as you can see here, we have a perfectly fine recycler view that contains our items. And now what we want to do is replace this traditional approach of setting text for a text view with the new pre-computed text approach, which improves performance. What's important to mention here is that obviously we're going to require a little bit more than just one line of code. Nevertheless, if you're developing a recycler view that performs expensive layout operations, you might want to switch over to the pre-computed text approach, which improves performance but requires a little bit more of code. All right. So what we first have to do is create a executor instance, because pre-computed text actually should be created on a background thread. So let's create a member here. I'll just call it background. I'm creating a scheduled thread pool executor with a pool size of 5, for example. And now we're going to get rid of this and implement our new pre-computed text approach. What we need for that is to use our background thread to execute the operation. And in here we now have to work with our text view and with the pre-computed text class. So let's create a weak reference here, not to ensure that we don't create any memory leaks. Which is what we can access now in here. So I'm accessing my text view from the weak reference. And then I'm creating my pre-computed text in the background. And as a data source, I'm going to use my data at the provided position. And what you can see here is that we also need pre-computed text parameters. And those parameters can be and have to be used from the text view. So we're going to actually get the so-called text metrics parameters from the text view. And it's very important that this is the same text view that you're going to set the pre-computed text later on. Otherwise, the pre-computation will not work. And we can now pass the parameters here. And in this variable, we already have our pre-computed text. So all that is left to do now is use our text view's post function, since we are on a background thread here. So by using post, we actually go back to the UI thread and then set our text view text from there. And in this case, we are obviously using the pre-computed text. So let's run our application again. We shouldn't actually notice any visible changes compared to the last execution, obviously because our layout is very, very lightweight, and the performance impact of pre-computed text will only visually show once you're creating very, very sophisticated layouts in your recycler view. So let's head back over to the emulator and view the results. As you can see here, the application works just the same. The only difference is we are now using the improved performance provided by pre-computed text to basically populate our recycler view.